Today I'm going to be talking about factoring polynomials. So remember, polynomials are just equations or expressions where we have things like in this example 3x and 36. So 3x, just a random term with a number, right, and an x. 36, that's a constant, right? It's just a number. And an example also might be like x squared, right? So everything's kind of in one line. There's no weird things like square roots or rational expressions like 1 over x. So we're just dealing with normal random numbers that aren't rational or radical. Okay, so whenever we factor equations or expressions, what we're trying to do is we're trying to make it simpler than what we started with. Okay, so factoring will do you well if you kind of start with a solid foundation, because as you go further in your math career, it becomes harder and harder to just kind of put off, because it really becomes necessary to solve some harder equations and questions. So factoring is really useful in making equations and expressions easier to work with. So what do I mean by that? Well, this first equation, y equals 3x plus 36, we can, like, whatever this y is representing, we know that the total y is going to be 3 times whatever x is plus 36. But to make this a bit easier, we can try and figure out if 3 and 36 have any factors in common. Okay, so what we want to ask ourselves is, can we divide 3x and 36 by the same number? Okay, so let's think, can we divide it by 2? If we factor out, okay, factoring out a number is just making it the coefficient, right, of that bracket. So if we factor out a 2, we need two numbers, right? Two numbers where 2 times the first number is going to give us the 3x, and 2 times the second number is going to give us 36. So can we do that? Well, 2 times 18 is 36, right? Because we can take 36 and just divide it by the 2 we factored out. We'll get 18, but 2 times what will give us 3x? Well, technically, if you're smart, or if you're not smart, but you're kind of quick with fractions, you know that 2 times 3 over 2x, the 2's will cancel and you'll just get 3x back, which is what we have, except when we factor these types of things, we only want whole numbers inside the bracket. So 3 over 2 is not going to do, and we only want whole numbers, so we're not able to factor out a 2 for this question. Next thing we have to ask ourselves is, can we divide 3x and 36 by the next biggest whole number, which is 3? Well, if we take out a 3, right, 3 times what will give us 3x? Well, 3 times x will give us 3x, so that part checks out. And then the second number, 3 times what will give us 36? Well, 3 times 12 will give us 36, because 36 divided by 3 is just 12. Okay, so if you want to figure out if you can factor out this number here, you take what is going to be on your inside and you divide it by what you're trying to factor out. So we started with 3x, we divided it by 3, right? The 3's cancel. This x is what's going to be on the inside. All right, same with the 36 and the 12. We divided 36 by 3 and we just got 12 back. Okay, so to verify that the factor forms an equivalent representation of the original polynomial, that just means expand it out and make sure that it's the same. Okay, so 3 times x, that's going to give us 3x, and 3 times 12, that's going to give us positive 36, and what do you know? This is exactly what we started with. So to verify that it's the same thing, we can just expand the factored form of a polynomial or expression, and if it is the same, then we know we're all good. So you might be thinking, why are we doing all this? Like, why are we putting ourselves through this task of factoring these equations and expressions? Like, what's the point? Well, if we wanted to try and figure out what, for example, y was, okay, let's say we know x was equal to 5. Okay, so for this equation, we're trying to figure out what y is when x is equal to 5. Well, let's say we didn't have it factored. Let's say we had to use this original equation, y equals 3x plus 36. You would have to plug in 5 for x multiply the 3 and the 5, and add 36 to that. So you would get 15 plus 36. Okay, either in your head or your calculator, you're going to figure out that y is going to be 51 when x is 5. Okay, but in our factored form, right, we know that y is equal to 3 times x plus 12. So same thing, we're going to plug in 5 for x, except now we're not dealing with big numbers like 15 and 36 and having to add those together. And you can imagine how big the numbers might get. All we have to do is multiply the 3 and 5 plus 12, which is 17. So 3 times 17, that's going to give us 51. Okay, so we get 51 for both answers because we factored it correctly, except for the factored version, we're dealing with much smaller numbers. We're dealing with 3, 5, and 12 instead of 3, 5, and 36. So it's a bit of a difference. So anytime that you see a common factor, it's called, you want to try and factor out that number. So in this case, that number was 3. And you always want to try and factor out the biggest number possible. Okay, so let's think of another example here. So this question is asking us to factor the function z equals 16x cubed y squared plus 48 y squared, and verify the factor form is an equivalent equation. Okay, so this is a little bit longer, and instead of y, we have this function z. So it's going to be 16x cubed y squared plus 48 y squared. So how can we factor this? Well, some people might see right away that 16 and 48 both have common factors of 16. But what if you didn't know that? What if you didn't have a calculator or you didn't know your 16's times tables, right? Well, since 16 and 48 are both even numbers, we can factor out a 2, and we're going to be left with 8x cubed y squared plus 24 by just dividing every number by 2, right? And if we keep doing this, we can bring out another 2, right? We're going to have 2 times 2 on the outside, which is going to be 4 times 4x cubed y squared, and I forgot a y squared here attached to the 24. So this is going to be plus 12y squared, right? And we can just keep doing this. We can keep factoring out 2's until we can't anymore. So we're going to get 8, divide that by 2, so 2x cubed y squared plus 6y squared. Do it again, right? Because 2 and 6 can also be divided by 2. So 8 times 2 is 16. X cubed y squared plus 6y squared. Okay, so we factored out the numbers in this equation. But like I was saying before, you can also factor out the 16 right away if you know your 16's times tables. Because let me just erase this again here. Okay, so if you know that 16 and 48 both have a common factor of 16, and you factor out that 16, what you're going to be left with on the inside is x cubed y squared plus 3y squared, which is what we ended with before. This is just a little bit quicker because we know instead of just taking out 2 every time, we can take out 16 all at once. Okay, so now that we have this 16 factored out, let's look at the variables on the inside that have common factors. So x cubed we have over here. Notice how the second term on the inside the brackets doesn't have any x's. So we can't factor out any x's because both of the terms don't have an x. Okay, the first one does, but the second one doesn't. So the x's, all of them are going to stay on the inside. But notice how both terms on the inside have a y squared. They have 2 y's being multiplied together. So that's also going to be a factor of this expression or this equation. So we can take out 16y squared, and on the inside we're going to be left with x cubed plus 3. Because if we expanded this y squared back in, we would get x cubed y squared plus 3y squared. Okay, so this is the fully factored version of the original equation. And again, you might be thinking, well, why are we doing this? We're putting ourselves through all this stress and work just to get this. What does that even mean? Well, like we did in the last question, if we're trying to figure out what z is going to be, right? Let's say we know that x is 2 and y is 2. Let's say they're both equal to 2. Well, plugging in 2 for x and 2 for y into this equation, that's not going to be fun at all. Okay, so you're going to get some answer after using your calculator, and it's going to be a bunch of steps, but plugging it into this equation that we just factored, right, we already took the 16 out. Y squared is going to be 2 squared because we know that y is 2. We're multiplying that by x cubed, so 2 cubed plus 2, right? 2 squared is just 4. 16 times 4 is 64. And we're multiplying that by 2 cubed plus 2. So 2 cubed is 8, plus 2 is 10. Okay, so this is going to be 64 times 10, which is just 640. So this question's a little bit longer. It's not the easiest equation to work with, but you get 640 in like 3 steps, where if you try to solve for z in this original equation, it would probably take like 8 or 9 steps. Okay, because you're just dealing with such big numbers and you would definitely need a calculator, where for this one, we were just multiplying 64 and 10, add a 0 onto the 64, it's 640, we're all good. Okay, now let's dive into questions where there's an x squared. All right, so it's not as easy as the first couple because we're kind of using a different method now. So the first few equations that we did here, we were just thinking of a number that went into both of them and we factored it out and it became our coefficient, right? So we had 2 terms in the equation, factored out something, and we were left with 2 terms still on the inside. Now we're starting with 3 terms, okay? So all that we're going to do for these questions, in the end, we want to get an x squared back. So what we do is we set up 2 brackets multiplying into each other, and each of them is going to start with x. Okay, so if we have the first bracket starting with x and the second bracket starting with x, and they're multiplying, x times x is going to give us x squared. Okay, and that's good because that's what we started with. We started with x squared there. So for all of these questions, we're going to start with 2 brackets, and each bracket is going to be multiplying that starts with x. Okay, and the last thing we're going to do is we're going to look at this 3 and this 2 and say, what 2 numbers multiply to 2 and add to 3? Okay, so if we think of our factors of 2, our options are 1 and 2, or -1 and -2, because remember, negatives multiplying make a positive. So we have to ask ourselves, between 1 and 2, -1 and -2, which one is going to add to this 3 right here? And the answer is +1 and +2. All you do is plug in +1, +2 into your brackets. Okay, so whenever you have x squareds with just a 1, like an imaginary 1 in front of the x squared there, you set up your 2 brackets, think of 2 numbers that multiply to the last number and add to the second number. Okay, and to verify this, right, we can expand this out. So x times x, that's x squared. X times 2 is +2x, right? 1 times x is plus x. 1 times 2 is +2. And if we want to combine like terms, right, x squared is still only x squared, but 2x plus 1x, that's going to be 3x plus 2. And you'll notice this is exactly what we started with. So to verify that our factoring was right, we can expand it out, see if we get the same thing, and in this case we did. Okay, and you can imagine that when these equations, these numbers get really big, factoring is going to make it a lot easier to kind of solve for y or manipulate equations however we need to, because two brackets with x plus 1 and x plus 2, that's a little nicer looking than x squared plus 3x plus 2, right? So that's kind of why we factor. Last question we're going to do here, same thing, x squared, so y equals x squared minus, actually this isn't an equation, so they didn't put y equals here, this is just an expression, so we don't need to worry about the y equals x squared minus 12x plus 36. Okay, so we need to think of two numbers that multiply to 36 and add to negative 12. Okay, let's think of our factors of 36, right? We got 1 and 36, negative 1, negative 36. We got, actually, I'll write it linearly, kind of in a line. Don't want to go into the next question. So 36, we can go negative 1, negative 36, negative 2, negative 18, negative 3, negative 12, right? Negative 4, negative 9, and negative 6, negative 6. Okay, and we could take the positive version of that. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. So we have to weigh out our options and see which set of two numbers is gonna add to negative 12. We all know they multiply to 36, but which one's gonna add to negative 12? And you'll find negative 6 and negative 6 are gonna add to 12. Okay. So if negative 6 and negative 6 add to 12, and they add to negative 12 and multiply to positive 36, our two brackets are just going to be x minus 6 and x minus 6. And whenever you have two brackets that are the same, multiplying each other, that's the same as x minus 6 squared. Okay, because when you're squaring something, you're really multiplying it by itself. And that's exactly what we're doing. We're multiplying x minus 6 by itself. So that's how you'd factor that question. And I lied, we actually have one more question here. Just a quick one, exactly the same process. So y equals, this one is an equation, right? Because that equals sign. Okay, so we need two numbers, right? We got our two brackets going here. Two numbers that multiply to negative 72 and add to the negative 1. So there's an imaginary 1 in front of the x there. So if we think of our factors of negative 72, we got negative 1 and 72, 1 and negative 72. And just for time's sake, I'm going to tell you that for our answer, negative 72, it's going to be negative 9 and positive 8. Because notice how these multiply to negative 72 and add to negative 1. Okay, so these are going to be our two constants inside the brackets there. Okay, and if we wanted to verify that we were correct, okay, what we would do is we would expand out both brackets. So we'd go x times x, x times 8, negative 9 times x, negative 9 times negative 8. So we would get x squared minus 9x plus 8x minus 72. Combine these like terms here. X squared minus x minus 72, exactly what we started with. Bingo bango, we are good. It's all factored. So I hope this video made sense. A lot to kind of cover with you. We started with factoring linear equations with two terms in them. Then we kind of threw in some variables there. And then we got into x squared. So these are called quadratic equations. X squared's in them. Remember, we got our two brackets there. And we thought of two numbers that multiply to the last number added to the middle one. We saw that anything where it was multiplying by itself, we could just write whatever that thing is squared. And then our last equation, right, kind of the same old. So hope this video made sense. A lot to cover, but I think we kind of broke it down and went through why factoring is important. So go back any point in this video and make sure that you understand everything, because like I said, moving on into your math career, having a good foundation with factoring is super important, and you're just going to breeze through all the questions if you're good at factoring. So, yep, have a nice day, and I'll see you in the next video.